Okay, this video is about series dilution factors and when you have more than one dilution factor to count. So, I teach math, but I've been studying some biology thanks to one of our Valencia professors, and I want to show you how to do that, how the math works for setting up dilution factors. So, this is my best understanding. You have some water you want to test that's got some bacteria colonies in it, and you want to be able to count how many are in it to decide if you need to boil the water or not, or how contaminated it is. But the problem is there's so much bacteria in that sample that you took that it's not countable. So in order to make it countable, you have to dilute it several times to be able to count how many is in the that water sample to make a decision about whether you need to boil it or not. So this is the sample, this test tube. These are, if you can't tell, my drawings are not that great, but these are test tubes. So what this is indicating is we're going to be diluting this. So this is the darkest, and then it's not as dark, and not as dark, and not as dark, and not as dark, and then it's lighter. It gets more diluted as we go. So this is just the math behind how you do the test tube. So here's the original sample with however many bacteria's got in it. So what we're going to do is take some of this and put it in this test tube. What is currently in this test tube without it, before we put anything in it, is 9.9 milliliters of some diluent, maybe water, but it's something that doesn't have any bacteria in it, so it's diluting it down. You can think of this simply as if you take a glass of water and you put a drop of lemon juice in it. The lemon, pure lemon, is very acidic, and it will not be nearly as acidic if you add it to water. And then if you keep putting that into more water and more water and more water, it's going to dilute it down and down and down. This is basically what we're doing. I just want to show you how they get these factors. It's really simple, but it might not seem simple until somebody goes through it with you. So here is our sample. So let's just say we're going to take 0.1 milliliter, 0.1 milliliter of the original sample, and we're going to put it into this test tube that currently has 9.9 milliliters of like water or something like that. So once I add 0.1 milliliter in it, now it went up just a little bit, right? So now the total amount is 9.9 plus 0.1 milliliter. These are milliliters. Okay, so the question is, what is the percentage of the sample in this, okay? Well, the total amount is 9.9 plus 0.1, and that makes 10. All right, so there's 10 milliliters after we add the 0.1 in. But what's the percentage of the sample in here? Well, it's 0.1 milliliter to 10 milliliters. So 0.1 is the same thing as 10 to the negative 1, if you change that to scientific notation. And 10 is the same thing as 10 to the 1, right? So in a different video, I talked about exponential factors. You could use your calculator to figure this out, but I talked about crossing the fraction bar. So if you did that, we have this 10 to the negative 1. If we raise him upstairs, it becomes 10 to the negative 1 over 1, and you can add exponents. This becomes 10 to the negative 2 over 1. So 10 to the negative 2 is a diluent factor for this test tube number 1. That's how they get that number. The next one I'll do a little faster, but it's the same thing. So here is the deal. What we're going to do, each one of these, every one of these test tubes, well no, these two, tube 1 and tube 2, have 9.9 milliliters of diluent. Okay, so what we're going to do is we're going to add 0.1 milliliter, same thing, all right? So this gets a little bit higher once we add that, and once we add that, the total amount, the total in the tube now is 9.9 plus 0.1, which is 10 milliliters. All right, how much did we put in? Well, we put in 0.1 milliliter of this test tube, which was 10 to the negative 2. We put in 0.1 of, or times, 10 to the negative 2. All right, well, let's figure out this guy's factor. So 0.1 is really 1 times 10 to the negative 1, or just 10 to the negative 1. That's what this part is. Okay. And we're going to multiply that by, and I'll just call it 10 to the negative 1. It's 1 times that, but it's the same thing. 10 to the negative 1 times 10 to the negative 2. All right, over this 10, which is 10 to the 1. Well, you can add, when you have like bases, you can add the exponents. This becomes 10 to the negative 1 plus negative 2, or 10 to the negative 3 over 10 to the 1. You bring them upstairs, 10 to the negative 3 times 10 to the negative 1 over 1. This, guys, is 10 to the negative 4 diluent factor. That's how they figure that out for test tube number 2. For 3, 4, and 5, how did they do this? Oh, these only have 9 milliliters. Okay, so this has got 9.0 milliliters, 9.0 milliliters, 9.0 milliliters. But this time, they're going to add not 0.1 milliliters, but 1.0 milliliter. All right, when we put that in, let's do test tube 3. I'm going to make more room. So what we figured out was, this is how they get these numbers. When you see this all worked out, if you're curious how they did the math for it, this is how it goes. This is going to be 10 to the negative 2 is what this one ended up being. 10 to the negative 4 is what that one ended up being. Okay, so here we go. We're going to add 1 milliliters of solution to 9 milliliters. So total is going to be 10. 10 milliliters is the total. All right, total. Okay, but how much did we add? How much did we put in of the sample that's been diluted? We put in 1 milliliter from test tube 2. 1 of, or times, 10 to the negative 4. All right, 1 times 10 to the negative 4 is just 10 to the negative 4. Divided by 10 to the 1. Bring him upstairs. That's 10 to the negative 4 times 10 to the negative 1, or 10 to the negative 5. That is what 10 to the negative 5 is the diluent factor for test tube 3. For test tube 4, they add 1 milliliter. 1 plus 9, the total, again, is going to be 10 milliliters. It's 1 milliliter of what? Of test tube 3 is what they added. 1 times 10 to the negative 5. So we've got 10 to the negative 5 over 10 to the 1. If you bring him upstairs, that's going to be 10 to the negative 5 times 10 to the negative 1, or 10 to the negative 6. That's how they get this diluent factor. Again, what if they add 1 milliliter? All right, 1 milliliter of what? Of, or times 10 to the negative 6 is what they've added. Once we add 1 milliliter, 1 plus 9 becomes 10 milliliters. This is a proportion. A proportion is something that doesn't hold units because the units are the same. So I'm just gonna, so this is, when they talk about proportions, you're comparing the same thing to the same thing. So this is milliliter to milliliter. So we have 10 to the negative 6 over 10 to the 1, which is 10 to the negative 6. Bring the 10 to the 1 upstairs. 10 to the negative 1. This is 10 to the negative 7. So if you were wondering how they get these little diluent factors, or how that works for these test tubes, that's the math behind that.